I know for a fact that one of these 10 problems will be on your next SAT. I know that because the SAT loves to repeat questions, and these are 10 of the hardest ones that they use over and over. I'm Risav Roy. I've scored a perfect 800 on the math section of the SAT multiple times now. And I know it's been showing up on these most recent tests because I go in person and take them. So here is my first prediction. My first prediction is that you will get questions on the SAT that almost seem to give you too little information, like this one. Let's read it. Triangle ABC is inscribed in a circle with a radius of 65. The length of AC is 130 and the length of BC is 120. What is the value of AB over BC? All we want to do is figure out what the question is asking and work backwards from there. It's asking for AB over BC. Let's draw it out first. We have a circle. We have a triangle. It's not perfect, but there we go. It's a little better. And let's label everything. Okay, radius is 65. The length of AC is 130 and the length of BC is 120. 130, BC 120. So really, if we work backwards from what the question is asking, all we are trying to find is AB over 120 because we're given that BC is 120. We can label AB as X. How do we solve this? Well, all we need to recognize is that if the radius is 65, then the diameter will be 2 times the radius, which is 65 times 2, which is 130. Do you see it yet? The only way that you can fit AC into this circle without it spilling out is if AC is the diameter. So I actually drew this incorrectly on purpose because AC has to be the diameter. That's a trick to solving this question. So AC is somewhere here. Let's erase all of this because we don't need it for now. This is 130. A is going to be right here. C is going to be right here. Okay. Now what? Well, let's clean a little bit of this up. Well, if this is 130 and this is 120, what we need to recognize here is we kind of need to memorize inscribed angle theorem. And that's how we'll know that this is 90 degrees. Inscribed angle theorem basically means that the central angle is going to be twice the inscribed angle. So in this case, this is the inscribed angle, and then this is the central angle, the diameter. And the diameter is 180 degrees. So the inscribed angle is going to be half of that, which is 90. We just need to memorize that. So I'll put a diagram up on the screen. Okay. From here, we can just set up an equation, a squared plus b squared equals c squared, where a is x, b is 120, and then c is going to be 130. Okay. If we zoom out, we get x equals 50. Now, we didn't solve the question yet because we need to always look at what the question is asking. It's 50 over 120, which let's put this into Desmos and then use this fraction button right here. 5 over 12. I guess we could have done that in our head, but that's okay. Let's move on. So my second prediction is that you're going to see these percent questions. What I call this is a percent chain. So let's do it. The density of an object A is 728% of the density of object B, and the density of object A is 0.07% of the density of object C. If the density of object C is P% of the density of object B, what is the value of P over 10,000? All right. Before we put this into Desmos, because the fastest way to do this is actually in Desmos, we want to write out the equations because we need to change it a little bit first. So the first equation is so A equals 728% of B. Now we can literally just leave it as 728% of B because anytime you type percent into Desmos, which is what we're going to do, you get percent of. Okay. The second equation is this, right? So you have your two equations. And before we do the third equation, we have to understand that Desmos doesn't like when you do 2A equals. It's kind of like defining the same variable twice. Desmos doesn't like it. So one of this has to be a B equals. And since the last one is going to be C equals P percent of B, we have a equals here, we have a C equals here. So we have to make this one a B equals. Did I put B here? It's supposed to be C, my bad. So yeah, we have to make this a B equals. How do we do that? Well, 728% is just 728 over 100. Anytime you do percent, it's just a number over 100. Just remember that. Percent is just a number over 100. Of is multiplied. B. Let's multiply 100 over 728 to the other side. 720, 100A over 728 equals B. And we can actually rewrite this entire thing. B equals 100A over 728. This is what we put into Desmos. So all we did is we figured out the three equations, which you can actually just put into Desmos immediately. And then we flip this from A equals to B equals. So each variable is defined once and only once. And we're literally going to type in percent. We're not going to do the over 100, not for the second and third equation. And then for this last equation, when we do this, we need one more step to make this work. We need to change the one that we are solving for into a tilde. So for whichever equation out of the three that has the variable that we are solving for, since we're solving for P, change the equal sign into a tilde. Whoa, like that. And see how it solves for P for you. No math required. Okay. We're looking for P over 10,000. P over 10,000, which is equal to 104. So you could totally do this by hand, but I would recommend you just put the equations to Desmos, make sure each variable is defined only once, and then put the tilde for the very last equation, 104. A 220-gram metal alloy is 55% aluminum. It contains a metal alloy that is 35% aluminum and a second metal alloy that is made up of 65% aluminum. What is the mass of the second metal alloy? Okay. This is my third prediction for the SAT that you're going to get these mixture questions. Basically, two objects combine to form one total object. Whenever you see questions like these, I just want you to think system of equations. So these are the mixture questions. Think system of equations. What do we do? The first one is actually more intuitive for a lot of you guys. Let's actually first define the variables. X equals the first metal alloy. Y equals the second metal alloy. And we do this so we don't get confused in the future. So then the first equation would be 0.35x plus 0.65 y equals 220 times 0.55. This one is more intuitive for most students for some reason, even though the second equation is simpler. This is the correct equation because all we're doing is we're taking the amount of aluminum in metal alloy 1 by multiplying 0.35 times x, and then adding it to the amount of aluminum in metal alloy 2 and setting it equal to the total amount of aluminum. X plus y equals 220 is our second equation. Why? Because we're setting the total grams of the metal alloy 1 plus the total grams of metal alloy 2 equals 220. So this actually should have been grams of first metal alloy. Same with y. Anytime you have a system of equations, just put it into Desmos. 0.35x, 0.65y. 220 times 0.55. Oh, I'm glad I double checked that. Okay. So for any system of equations, the intersection point is going to be our solution. So let's export this point by clicking this button. And what are we trying to find? We're trying to find the mass of the second metal alloy. So why? Because that's what we labeled right here. See how doing this part, even though it takes, a little more time, is important? Okay, we all know that 0.666 repeated is just 2/3. So we just do this, and to get an exact answer, you press this fraction button, right? So 440 over 3 is our exact answer. This is the mass of the second metal alloy. Anytime you see a mixture question where two solutions, two liquids, two metal alloys are being mixed together, and it gives you the percentages of each system of equations every single time. Okay, this is my fourth prediction. You're going to see questions that say a quadratic function as a word problem, and it's the same question every single time. So I'm going to show you what this looks like. A quadratic function models the height in feet of an object above the ground in terms of time and seconds after the object is launched. The model indicates that the object launched from the ground and reaches its maximum height of 600 feet above the ground 10 seconds after being launched. Based on the model, what is the height in feet of the object above the ground 14 seconds after being launched? What do we do here? These questions, when it gives you a word problem that starts with a quadratic function, is the same question every single time. It gives you 2 points on a parabola, one of them being the vertex, and then it tells you find the parabola that goes through these 2 points because they want to find like the y value of some random point on the parabola. So what's the first step? First step is find the 2 points. Let's start there. What are the 2 points? Well, the first one is 10,600. Why? 10,600 is this right here. So after 10 seconds, it's 600 feet above the ground. And it also says it is the maximum height. So this is equal to the vertex. Okay. Now, what we can do is if we memorized vertex form, I know there are ways to do this on the calculator, and I have videos on how to do that in my other videos. But I want to show you like how to do this by hand so you know why the calculator stuff works when you watch my other videos. But so here's how to do this by hand. You first write out vertex form. You need to memorize vertex form, right? Then you know that this is h and k because the vertex is h comma k. So you plug that in. X minus 10 squared plus 600. Now what? Well, we need to find our second point. And our second point is actually pretty tricky because it indicates that the object is launched from the ground. This gives us our second point. Why? Because when it says it's launched, that's at 0 seconds. Because the 600 is only in reference, never mind. This 10 seconds is only in reference to the launch. So this is 10 seconds after launch. So launch would be 0 seconds, if that makes sense. Now, when it says the ground, it's the same thing here. The 600 feet is only in reference to the ground. So this is 600 feet above the ground, and the ground would be 0. So when it's launched above the ground, that means it's 0 seconds at 0 feet. So 0, 0. What do we do from here? We just plug in 0, 0 into our equation. So this is x and this is y. Since we have our vertex form, 0 goes in for x and y. And typically from here, once you have one variable and an equal sign, Desmos can solve it for you. Just replace whatever variable it is with x, right? Equals x times. And by the way, we're only replacing a with x temporarily. This is still a, but Desmos only likes x and y. Okay, now if we press this home button, let me show you one more time, this home button right here. We go back to the default view. Okay, we have a is equal to -6. Perfect, because this is a line of x equals -6. We know what a is. We have our function. From here, honestly, I would just put the entire function into Desmos. So f of x is equal to -6 times x minus h, which is 10 squared, plus 600. And then on the next line, you have to do this in two separate lines. You have to first define f of x, and then find the random point that asks you to find. So f of 14, whatever that is, f of 14, 504. Okay. Hopefully all of that makes sense. Let's recap real fast what we did. These problems are always the same because um, it's always a word problem that starts with a quadratic function. When you see that, find the 2 points. One of them is going to be the vertex, so put it into the vertex form, right? Solve for a by plugging in the second point for x and y, and then put it into Desmos by putting the entire function into Desmos, and then do f of whatever random point it asks you to find. Okay. Functions f and g are defined by the equations shown, where a and b are integer constants. A is greater than b, and b is greater than 0. If y equals f of x and y equals g of x are graphed in the xy plane, which of the following equations displays as a constant or coefficient the maximum of the graph of the corresponding function when x is greater than or equal to 0? What does this question even say? We want to find the maximum of the graph as long as x is greater than or equal to 0 of both of these graphs, and then figure out if it's displayed as a constant or coefficient. What does that mean? Let's start with f of x. B times 0.92 x plus a. Now, I'm not going to put this into Desmos right now. You totally can. But if you put in all of this, what you'll notice is that as long as x is greater than or equal to 0, the y-intercept, so when x equals 0, is going to be the maximum point, no matter what b is, no matter what a is. And that's because this is a decreasing exponential function. Let's graph only this part. X. Oh. And if we do a domain like this, x is greater than or equal to 0, this decreasing exponential function, as long as x is greater than or equal to 0, will always have the maximum value at x equals 0, because from there, it's always just decreasing. It's only downhill from there. Okay, f of 0 and g of 0. So let's first find the maximum values. Be 0.92, 0 plus a, which just simplifies down to a. So this is the maximum of f of x. What's the maximum of g of x? B times 0.92 to the power of 0. And this simplifies to 1. Anything to the power of 0 is 1. But the b does not go away. Just b plus a. Okay. We have to look at each of the constants and coefficients in each of these graphs and make sure, like, does it equal exactly the constant or coefficient? So what do I mean by that? What are the constants and coefficients in here? Well, the coefficient is going to be the b. The constants are just going to be a and b. So in total, it's just a and b that we are looking for. Does this equal to a? This. Does it directly equal to a? Is it a? No, it's not a. Does this equal to b? Does it directly say that it's b equals b? No, this is not b. This is b times 0.92 to the power of a. So this question is actually more simple than you think, but it's one of those constant and coefficient questions that you might have seen before. It's a lot of words just to say, does the maximum of the function equal the constant or coefficient? So let's go down here. And a lot of you guys might have answered B, but the problem is B is wrong. And the reason why is because if we take a look at the constants and coefficients here, it's A and B. B is not only the constant, but it's also the coefficient, and A is a constant. So does this equal to A? Does B plus A equal to A? No. Does B plus A equal to B? No. B plus A is B plus A. It is not A. It is not B. So the answer is actually D. It's actually neither. Neither of them work. Now you might say, well, B plus A is a constant, but that does not matter. Because even though a constant plus another constant will form another constant, B plus A is two constants added together, and this only says constant singular. So 2 is just wrong. Okay. The table shows the distribution of 90 basketball players and their positions on a basketball club. Each player is categorized in one position. It gives you the table. And then if one of the 90 players is selected at random, the probability of selecting a player who is categorized as a power forward, given the player is not categorized as a shooting guard, is 4/15. How many of these players are categorized as a center? Work backwards from what the question asks you to find. So we want the amount of centers. Well, if we take a look at this, we have 34 power forwards plus centers. Now, how do you find the number of centers from here? Well, we subtract the power forwards. How do you find the number of power forwards? By using this proportion. 4/15 of the players that are not shooting guards are power forwards. So how many players are not shooting guards? 90 minus 15, because there are 15 shooting guards. So we multiply 4/15, which is our proportion. So 4/15 of these players are power forwards. So 20. Let's recap real fast. So 90 minus 15 is going to be the number of players that are not shooting guards. So basically this proportion, 28 plus 13 plus 34. Now, 75 players, out of the 75 players, 4/15 are power forwards. So 4/15 of 75, which is 20. Let me erase this. 20 players are power forwards. That is not our answer yet, because 34 players are power forwards or centers, minus 20, which is 14. That's how many players are categorized as a center. Okay. In the figure below, lines A and B are parallel. What is the value of x plus y? Okay, here's what we want to do. We know that these lines are parallel, these ones. So what we can do is we can translate this down here, 114 degrees. Now, if we zoom into here, what we'll notice is that this angle right here is x plus 114. Let's put that into parentheses. Now, this angle right here is supplementary to this angle, meaning they add up to 180 because they're on the same straight line. So this would be 180 minus x plus 114. Same thing here. This is y plus 127. We can remove the degree sign for now. We don't. It's irrelevant. This is going to be 180 minus y plus 127 because it's just 180 minus this. And we know that this is 79 because of vertical angles. And we can add up all three angles and set them equal to 180. The problem is that we can't do this on Desmos because there are two variables. And we only have one equation for two variables. So we have to do this by hand because we're solving for x plus y. We're not solving for, we don't care about x or y individually. That's what I mean. We only care about x plus y. Notice how I'm being very careful with the parentheses. Make sure you don't drop the parentheses, otherwise you're going to get it wrong. And all of this is equal to 180 because this is basically angle A in the triangle. This is angle B right here. And then this part is angle C. Let's simplify. Okay. What's 79 plus 180? And then I'm going to do all of the calculations at once, like all of the numbers at least. Plus 180 minus 127. So then 198 minus x minus y equals 180. Here's what we want to do. Let's remember that 198. Oh man. Let's just erase this. Multiply both sides by -1. Be very careful when you're multiplying by -1. I've seen a lot of students mess up here. X plus y equals 18. And what are we solving for? X plus y. Our answer is 18. So the hardest part is just figuring out that what these angles are, right? These angles are just supplementary to the angles next to them. And the angles next to them are just y plus whatever angle is right here. Two numbers r and s are each greater than 0, and the fifth root of r is equal to the ninth root of s. For what value of x is r to the power of 5x minus 4 equal to s? Okay, what do we do from here? Let's write out the equations first. Ignore this for what value of x, and just write out the next equation like this. 5x minus 4 is equal to s. The reason why this doesn't matter is because all this is saying is solve for x. That's it. It's just trying to throw you off by putting it at the beginning. So these are our two equations. If you were able to find these, then awesome work. What do we want to do from here? Well, let's take this to the power of 9. And the reason why is because then this turns to fifth root of r to the power of 9 equals s. Because we just took out the root. Now we can set these equations equal to each other. We can actually replace this s with this. Now, what is the fifth root of r to the power of 9? Well, if we want to put this as a fraction, then the exponent is always the numerator, the root is always the denominator. That's the simplest way to think about it. It works every time. R to the power 9/5. And now, since it's the same base of r, we can finally set these equations equal to each other. We couldn't have done it before because it was in s and r. Now we can. 5x minus 4 equals 9/5. Okay. We zoom out 1.16. And then what are we solving for? Perfect. We're solving for x. So we got the right answer. Or at least we solved for the right thing. Let's move on. So this is a different type of percent question than the one that you saw earlier in this video. Let's go through it. After 0.2 of the original coins in a collection were removed from the collection, 53,892 coins remained in the collection. How many coins were removed from the collection? Here's what we need to know. 0.2% is some unknown number. That's what we're solving for. But we know what 99.8% is. 99.8% of the entire collection. So let's say of C, because C is the collection. Let me erase this. 99.8% of the entire collection is equal to 53,892. Can't we just put this into Desmos and then change this into a tilde? Just like something similar that we did at the beginning of this video. Okay, let's try it. And instead of the equal sign, we're going to put a tilde. 53892. So the entire collection, which Desmos just solved for us, is 54,000. So how many coins were removed? C minus 53,892. 108. That's it. Set up this equation, put this in. I will say, as a tutor, I've seen a lot of students do questions like these. The biggest mistake that I've seen is actually a really simple one that you can avoid. It's just putting in the numbers wrong into Desmos. Make sure that you are double checking when you put everything into Desmos, please. I don't know if you saw that, but you can replay the video. I was being very careful when I was entering the numbers. I actually looked at this number. I didn't even look at the stuff that I write. I look at what the question says because I might have wrote it wrong. All right. This is the last one. This is question number 10. You ready? This one's a tricky one. I shouldn't have told you that, but let's keep going. The triangle inequality states that the sum of any two sides of a triangle must be greater than the length of the third side. If a triangle has side lengths of 32 and 68, which inequality represents the possible lengths of x of the third side of the triangle? Now, a lot of you guys, when you do this question, the answer you might have gotten is B, but B would be incorrect. The answer is actually C. Why is the answer C? Because if we think of a triangle and we think side 1 is, let's say, x, side 2 is 32, and side 3 is 68, then yeah, x does have to be greater than 36. You're right, because 68 minus 32 is 36. Let's check that. 68 minus 32. Perfect. So basically, you're taking side 3 minus side 2. But what if, instead of this, what if side 1 was 32, side 2 was 68, and you didn't know what side 3 was? Then side 3 has to be bigger than the two sides. It actually has to be smaller than 100 because 60, why did I write 63? 68 plus 32 is 100. So not only does x have to be greater than 36, but x also has to be less than 100 because 32 and 68 could be the smaller sides. If you want me to personally walk you through the areas that you are personally struggling in, go ask your parents to sign you up for a private one-on-one tutoring session with me at thesatmath.com. As for your next SAT, I would wish you good luck, but I know you don't need luck because you're going to crush it. I'm rooting for you. Bye-bye.